This is a video on factoring expressions of the form x squared plus bx plus c. And I want to make a note that b and c are constants here, and x squared and x are going to be variables. And just this little note here, you're going to use this when you're factoring an expression that contains three terms, which this does, and the leading coefficient is 1, meaning that the number in front of x squared here is 1. That's why I don't put a variable there, because it's always going to be a 1 in front of x squared when you use this factoring method. So our steps, alright, our first step is to find two numbers that multiply to c. So when I say multiply to c, I mean they have to multiply to whatever the last term is, and they also have to add to b, alright, whatever that middle coefficient is. Alright, once you've found those two numbers, alright, you're going to use those two numbers to write expressions as two factors in the form x plus one of the numbers, alright, so this will be like the first number in step 1, times x plus the other number that you found in step 1. Alright, this will give you the factored form of that trinomial, of that expression up top. Alright, once you have that, you're done. You factored it. You can always check this by foiling. Let's take a look at an example here. So we're going to factor x squared plus 13x minus 30. Now whenever you factor, the first thing you should look for is a GCF. In this case, there is no greatest common factor to all three terms, and there won't be for anything in this form because the coefficient of x squared here is going to be a 1, right? There is no number in front of x squared, so it's really a 1 there. And there won't be any common factor to factor out other than 1 since this doesn't have any other numbers there. Since there is no GCF here, and we have three terms, our coefficient here is 1, meaning there is no number in front of x squared. That tells us that we're going to be allowed to factor with our two sets of parentheses right away and an x in front of each of them. Alright, and we want to find the numbers that go in the blanks here by using the method that we just described. We want numbers that multiply to a negative 30, and those two numbers also have to add to the middle term, which is a positive 13. Alright, so they're multiplying to c, which is negative 30. Make sure you take the sign with it. Alright, and they have to add to 13, the middle coefficient. And the numbers that do that are 15 and negative 2. Right, 15 times negative 2 does equal negative 30. 15 plus a negative 2, well, that does equal a positive 13. So we can fill in the blanks with a positive 15 and a negative 2 here. So this will be plus 15 and x minus 2, and then we factored it, right? So our factored form is just x plus 15 times x minus 2. And we're done. To check this, you can always FOIL. Alright, so we could just, distribute through by foiling and see that we got the original expression. Something important to notice here. Since we had to multiply to a negative 30, since this last term was negative, that told us that our numbers had to have opposite signs that we were finding. One had to be positive, one had to be negative, because that's the only way you can multiply to a negative number. This sign being positive told you that the larger number would have to be positive. So that's how you know the 15 is positive and the 2 would be negative. Let's take a look at another example. We'll factor x squared minus 6x minus 27. Again, we have three terms. That's the first thing you should look for. And, is there a GCF for the whole thing? Well, there can't be a GCF for the whole thing because the coefficient of x squared here is 1. So, since the coefficient of x squared is 1 and we have three terms, alright, we can right away make our two sets of parentheses. We know it's going to factor like this, and you're going to have x in front of each of them. Alright, and now we want to figure out how we're going to fill in our blanks here. Well, we need numbers that multiply to whatever c is, in this case negative 27, and they also have to add to whatever the middle coefficient is, which is a negative 6. So numbers that do that, let's try negative 9 and a positive 3. Negative 9 times 3 gives us a negative 27. Negative 9 plus 3, that does equal negative 6. So we found the two numbers. These numbers are always going to be unique, meaning that there's only going to be one way of finding the numbers. There's not more than one way numbers could multiply to negative 27 and add to negative 6. So the numbers we found were negative 9 and positive 3. So we can fill in our blanks with negative 9 and positive 3. And then we've done it. We factored it. Alright, so x minus 9 times x plus 3. And to check this, you can always FOIL. We'll do a quick check here just so you can see it. X times x would give us x squared. X times a positive 3 would give you plus 3x. A negative 9 times x would give us negative 9x. And a negative 9 times a positive 3 would give us negative 27. Combining like terms here in the middle, we have this is equal to x squared. A plus 3x minus 9x is a negative 6x. And then minus 27. That is the original expression, so it checks out. Alright, but the answer is the x minus 9 times the x plus 3. The check is optional. It's for you to check your own work. Let's take a look at one more. If we're to factor x squared minus 4x plus 3. Alright, first, there is no GCF for the whole thing. Alright, there is no factor that I can take out of all of them except for one. So we're not going to factor out a GCF. We have three terms, and the coefficient in front of x squared, since there's no number in front here, is 1. That tells us that you can right away make two sets of parentheses, and we need x and x here, because think about it, our first step of FOIL, x times x equals the x squared, so you know those are going to be x. It's always based on whatever this is being squared. If that said y squared, you would have y times y here. Since this is x squared, you need x times x. Once we have that, we're going to figure out how to fill in our blanks. We need numbers that multiply to whatever c is, the last term, so we need to multiply to a positive 3. And they also have to add to the middle coefficient, which is a negative 4. Make sure you take the sign with it. So numbers that multiply to 3 and add to a negative 4. Well, this sign being positive here on the 3 tells you that when you multiply to a positive number, either both numbers are positive or both numbers are negative. So we know that the signs have to be the same. This being a negative 4 here tells you that since numbers have to add to a negative 4, they both better be negative. Because if there were two positive numbers that multiply to 3, they would never add to a negative 4. So we need numbers that are going to have the same sign. That's what the plus sign here tells you. The negative here in front of the 4 tells you that sign is going to be negative. Alright, so numbers that multiply to 3 and add to negative 4, well, it would be negative 3 and a negative 1. Negative 3 times negative 1 is a positive 3. Negative 3 plus negative 1 does equal negative 4. So we found the two numbers. Then we can just fill them into our blanks here. So we're going to have x minus 3 and x minus 1, and then we've got it. X minus 3 times x minus 1. You could check this on your own by foiling, remember. And it's important to recognize how we got the signs here. Alright, things that multiply to a positive, meaning they have the same signs, they have to add to a negative, so that means the signs both better be negative.
Alright, let's take a look at a few other examples here. So, if I was to ask you to factor, we'll do a few of them, so I'll call this one A. This first trinomial I'll say is x squared plus 16x plus 63. So, first thing when you're factoring, you should always look for greatest common factor. In this case, I don't see one other than 1, so I don't need to factor out. I should notice I have three terms, and when I have three terms, if I notice I don't see a leading coefficient, in other words, a leading coefficient is 1, then right away I can make two sets of parentheses to reverse FOIL this. And since we know the first step of FOIL gave me the x squared, I know the first part of each of these is x times x. And I want numbers that multiply to whatever c is, so multiply to a positive 63. And they also have to add to the middle term, or the middle coefficient, which we called b, which is 16. So we want numbers that multiply to 63 and add to 16. And knowing your multiplication facts here helps. But the numbers that do that are 7 times 9, right? 7 times 9 equals a positive 63. 7 plus 9 does equal 16. They're both positive, you know that, because to multiply to a positive number, you either have to have them both be positive or both be negative. But to add to a positive, you know they have to both be positive. So we have positive 7, positive 9. You can fill those in. So x plus 7 times x plus 9. Remember, you can put these in the reverse order here. If you wrote x plus 9 times x plus 7, that's fine, because multiplication can be done in either order, right? It's commutative. Let's take a look at another one. If I wrote x squared minus 5x minus 24. Again, we're going to factor here. And to factor this, first thing you look for is a GCF. In this case, I don't see a greatest common factor other than 1. So we can't factor anything out of the entire thing. You should count the number of terms you have. I have 3 terms. And because I don't see a value in front of x squared, in other words, I see, leading coefficient that's just 1, right away I make two sets of parentheses. And remember how this works. X squared came from your first step of FOIL, so we know we need x times x here. And we want numbers that multiply to c, so multiply to a negative 24. Make sure you take the sign with it. And they have to also add to whatever b is, the middle coefficient, which is negative 5. So when I go to pick these numbers out, right, multiplying to a negative tells me the signs have to be opposite, because the only way you can multiply to a negative is if one's positive and one's negative. Adding to a negative in this case tells me that the larger number in absolute value should be negative, because that's how you're going to add to a negative. The larger one's negative. So again, knowing your multiplication facts here helps. Numbers that multiply to a negative 24 and add to a negative 5 would be negative 8 times a positive 3. That would give you negative 24. Negative 8 plus 3, that does give you negative 5. Remember, these numbers are unique, so if it works, there's only going to be one way you can find these numbers. And then you can just pop them in as x minus 8 and x plus 3. If you put the positive 3 first and the negative 8 second, that's okay, but make sure that, you know, the same sign stays with the same number. So negative has to stay with the 8, positive stays with the 3. Remember, you could always check these by foiling, right? Distributing through and making sure you get the original problem. Let's just take a look at one more here. If I wrote y squared plus 18y plus 81. So again, the directions are factor. And to factor this, you know, first thing you should look for is a GCF. In this case, a greatest common factor for all three of these. The only thing that I would have is 1, so you don't have anything to factor out. Next thing you should notice is how many terms you have. We have 1, 2, 3 terms. If I have 3 terms and I don't see a value in front of my y squared, in other words, the leading coefficient is 1, right away you can make 2 sets of parentheses. Now, be very careful with the variable here. The variable is y, so to get a y squared from the first step of FOIL, I would have needed y times y. Make sure you're careful about that. If you don't use the correct variable, if you always try to use x, for example, you know, you might get it wrong. And then I need numbers that, remember, multiply to whatever the last term is. So multiplies to 81, multiplies to c. And they have to add to whatever the middle coefficient is. It's a positive 18. And you had to ask yourself what numbers multiply to 81 and add to 18. Well, multiplying to a positive tells me that both numbers are going to be either positive or both numbers are going to be negative, right? They're going to have the same sign. Adding to a positive tells me that better be positive. So this will be y and then plus and plus. And then the numbers that multiply to 81 and add to 18, well, it's 9 times 9. 9 times 9 gives you 81. 9 plus 9 equals 18. So we have y plus 9 and y plus 9 here. You could leave it like that if I just asked you to factor. But more typically, when you multiply something by itself, remember, we usually say it's that thing squared. So I'd write this as y plus 9, that whole quantity squared. You need the parentheses around it. I'd probably give you credit if you wrote it like this, in terms of just y plus 9 times y plus 9. But remember, when you have something times itself, you do write it as squared. What you can't do is bring this 2 in here and say this is y squared plus 81. That'd be incorrect, because remember, that's not the original problem. So you have to leave it like that. Why don't we take a look at a couple more examples. If I asked you to factor this one here, if I said I had x squared plus 5x plus 15. So if I aim to factor this, you know, I'm going to be picking out, you know, a GCF if I can find one. Now, there is no greatest common factor here, right? These first 2 terms both have x, but you can't take an x out because the last one doesn't. The last 2 terms both have 5, but the first term doesn't. So you can't factor anything out in terms of a GCF. And then when you're looking at this, you count the terms. We have 3 terms, and then you're looking at the leading coefficient. If I don't see a value in front of x squared, to try to factor this, I put 2 sets of parentheses. To get an x squared, I need x times x. So if I have x times x there, that's giving me the x squared. And now to figure out what goes into the rest of it, remember, I want numbers that multiply to whatever c is, the last term. So multiplies to 15, and they have to add to the middle coefficient, whatever b is, so they'd have to add to 5. Now, trying to find these numbers, you know, it's kind of a trial and error. You got to kind of know the factors of 15. Well, multiplying to 15, we're either going to do 1 times 15 or 3 times 5. Right, those are the only ways you really can multiply to 15. Since it's a positive, I know that both of these should be the same sign. Since the middle term is positive, I know I would have to be adding them to get a positive, so they should just be positive numbers. Well, 1 times 15 gives me 15, but 1 plus 15, that equals 16. So that's incorrect. That won't give us a 5x in the middle. 3 times 5, well, that's 15, but 3 plus 5, that equals 8. So we know that doesn't work. So if I'm looking for numbers that multiply to 15 and add to 5, I can't find any because I have all the factors of 15 here. So what that tells me is that this is not factorable. So we call these prime polynomials. All right, so we say it's prime, and we call it prime because it's just like a prime number. The only factors it would have are 1 in itself. In other words, it doesn't factor down to anything except for 1 times itself. So it's a prime polynomial. Or the other way you might see this written is unfactorable. So you should answer in one of those two ways if something isn't factorable. You know, not everything is factorable. A lot of things are, but not everything. And it's important to know which is and which isn't. So when you take a look at this, just be aware that it's a possibility to have prime or unfactorable. It won't happen very often because we're trying to test your abilities, but you do want to make sure you can identify it if it is. All right, let's take a look at another example here. If I said I had x squared minus 3xy minus 18y squared. So when I look at this, first thing I'm looking for, is there a GCF? I'm trying to factor this. And in this case, there is no greatest common factor. The first two terms have x. The last one doesn't. The second two terms will have y. The first one doesn't. They also have a 3 and 18. Could take a 3, but the first one doesn't. So no greatest common factor for the whole thing. You should count the terms you have, which is 3. When I have 3 terms, I'm looking at the leading coefficient. In this case, the leading coefficient is 1. In other words, I don't see anything there. So that's what tells me right away I can make 2 sets of parentheses. And to get the x squared in front, you know, we get x times x in our first step of FOIL. The other thing to notice in this one is that you got this extra variable, right? We didn't have it in the previous examples. You got this y squared at the end. Well, that just means I'm going to have a y times y, because I know it comes from my last step of FOIL. So y times y will give me a y squared. And then you do everything else like you normally would. So I still want to find things that multiply to whatever c is. In this case, c is going to be negative 18. You don't use the variable with it because we're taking care of it in here. And then we want numbers that add to whatever the leading or the middle coefficient is. The middle coefficient is negative 3. So to find values that do that, you want numbers that multiply to negative 18 that also add to negative 3. Well, which numbers do that? We've got a negative 6 times positive 3. That gives me negative 18. Negative 6 plus 3. That does equal negative 3, so it works out. Remember, these numbers are unique. The only numbers that can do this are negative 6 and 3. So what you do is then you just pop those in right attached to the y's at the end of each of these. So x would be minus 6y and x plus 3y, and that's how it factors. So don't let that little extra, y variable throw you off. Sometimes people kind of ask me, like, what happened with the middle though? Why is it xy? Let's take a look at what happens if you were to check this by multiplying through using FOIL. So you have x minus 6y times x plus 3y, right? So this is my check here. And foiling this, right, means first is x times x, which gives you x squared. The outside is x times a positive 3y, so plus 3xy. The inside is negative 6y times x, which I can write as negative 6xy. Typically we write in alphabetical order. And then the last, negative 6y times a positive 3y. Negative times a positive makes it a negative. 6 times 3 is 18. Y times y is y squared. And then all we do is combine like terms. Combining like terms here, I have x squared. A plus 3xy minus 6xy is minus 3xy. And minus 18y squared. So the check works out because it's what we had originally over here. That's how you know you factored it properly. The xy term, this part here, just comes out as a result of our FOIL, right, of the outer and the inner. So you don't use it when you're actually factoring. You're really using the ends more, and this will always be one of each of the variables. But don't let it throw you off, right? So if you see this y squared at the end, just know you're going to have a y times y there. but then you handle the coefficients the same way. And let's take a look at another example. If I said to factor 2x squared minus 8x minus 42. First thing when you're factoring, you should look for a greatest common factor every time. In this case, greatest common factor, we do have one. Don't always assume there isn't, right? We have a 2, an 8, and a 42. So you're looking for a GCF for the whole thing. So the GCF is 2. So I'll factor 2 to the front. And then remember in parentheses after, when you take out a GCF, you're just dividing 2 from each term. So this ends up being 2x squared divided by 2 is just x squared. Negative 8x divided by 2 is negative 4x. And negative 42, factoring out the 2, is negative 21. Once you're in here, remember when you factor out a GCF, the GCF stays in front for the rest of the problem. So 2 just comes right down. And then we want to look inside the parentheses. Now inside the parentheses, you want to follow your same procedure. We already took out a GCF. Now I want to count the number of terms. I see 3 terms. And do I see a value in front of x squared other than 1? In this case, no, the leading coefficient is 1. That tells me right away if I'm factoring this, I need 2 sets of parentheses. For an x squared, you need x times x for your first step of FOIL. And you want things that multiply to. Now remember, you're using what's in here. Don't use the original problem. You're using what's inside to factor this. So then multiplies to a negative 21. It has to also add to a negative 4, your middle coefficient. So numbers that do this, keeping in mind, multiplying to a negative tells you the signs have to be opposite. Adding to a negative tells you that the larger one in absolute value should be negative. So to multiply to a negative 21, that would be negative 7 times positive 3, right? That'll give me negative 21. And negative 7 plus 3, that does equal negative 4. So remember, these numbers are unique. We found the numbers that do it, so I'm just going to put x minus 7 and x plus 3 here, and then it's factored. You have a product. You have things multiplied together. You don't need to bring down these parentheses here because you factored it down into something that's all a product. It's all being multiplied. And we'll just look at another example just to make sure you got it. If I said to factor 4x squared plus 20x minus 144. Again, first thing you're looking for is a greatest common factor. In this case, we do have a GCF. 4, 20, and 144 all have a common factor of 4. You can't take out any variables because there are no x's in the last term, but there are on the other two. So the GCF is 4. Comes out in front. Remember, when you factor out a GCF, you're going to just divide it out from each term. So 4x squared, taking out the 4 gives me x squared. 20x factoring out the 4 gives me a plus 5x. And negative 144 factoring out the 4 gives me negative 36. Make sure you have parentheses around this. Also, don't try to skip a step. Sometimes people try to go from the original, take out the 4, and then try to factor it all at the same time. You need to do this middle step. If you don't do this, you're not going to get the final answer correctly. Once I'm here, remember, GCF out in front stays in front for the rest of the problem. Inside, you want to follow your procedure. You took out a GCF already, so the next thing you want to do is count the terms. We have 1, 2, 3 terms here. I don't see a value in front of my x squared, meaning the leading coefficient is 1. So right away, I can make 2 sets of parentheses and reverse FOIL this. X squared tells me I have x times x for my first step of FOIL. What numbers that multiply to, you have to use what's in here. Multiplies to a negative 36. Don't use the original. All right, and it has to also add to a positive 5. So multiplying to a negative 36 tells me that the signs are going to be opposite, because that's the only way you can multiply to a negative. Adding to a positive 5 tells me the larger one in absolute value should be the positive one. So I'm going to look for the numbers that multiply to negative 36 and add to a 5, and I got 9 and negative 4. 9 times a negative 4 is negative 36. 9 minus 4, that does equal 5. So those are the numbers you're going to use here. Right, 9 and negative 4, so positive 9, make sure you put the plus with it, minus on the 4, so x minus 4, and this is a product. We're done with it. We have 4 times x plus 9 times x minus 4. And we'll just look at one more. If I said to factor this, negative 14x plus x squared plus 48. The first thing I would recommend when you're factoring is actually write this in descending order. So if you don't write it in descending order, you can't follow the rules that we have about A, B, and C. So when I want to write this in descending order, I want the highest power first. It's a positive x squared, so I'm going to write x squared. The next term would be a negative 14x, and then the constant term last, so plus 48. Now once I've done that, now I'm ready to try to factor as I normally would. In this case, I'm looking for a GCF for the whole thing, and I don't have a greatest common factor other than 1, right? There's no GCF I can take out of all 3 terms. So there is no GCF to take out. And the second thing I want to look at is counting the terms. So I have 1, 2, 3 terms, and when you have 3 terms, you look at the leading coefficient. If I don't see anything in front of the x squared, that means the leading coefficient is a 1, so we can make 2 sets of parentheses right away. X squared, reverse foiling this, tells me it's x times x. I want numbers that multiply to a positive 48 and add to a negative 14. Multiplying to a positive tells you the sign should be the same. Adding to a negative tells you that both signs better be negative, because if you're multiplying to a positive number and you're going to add to a negative, then both numbers that multiply to give you the positive better be negative. So multiplying to a 48 and adding to a negative 14, I've got negative 6 times negative 8. That does give me a positive 48. And negative 6 plus negative 8, that does give me negative 14. So the numbers are x minus 6 and x minus 8. So hopefully this helps in factoring. The important things to remember is, you still want to look for a GCF first. If there is one, you want to factor it out like we did in these problems up here. And if you do factor it out, right, then you follow the rest of the process, which is count the number of terms you have. And when you have 3 terms and you don't see a value in front of your x squared, meaning your leading coefficient's 1, then you can make 2 sets of parentheses right away. In the next section, we'll talk about what happens if you can't factor out that GCF to make the leading coefficient 1, and how you would actually handle problems like that. It's a little different than what we did here.